Hi there, just very quickly because the video is a bit over 20 minutes anyway. I do these calculations in one go, okay? So both of these calculations, this is the submission question from yesterday, I do them all in one go. So I write it out, but then here I did shift cos of that, and here I just did the square root of that, so in one go. However, important point here was that the answer to A was recycled in B. So make sure that you store the exact value on your calculator. And when you then use it down here, you use that stored value. So I think I stored it in memory A, so I just typed in A squared at that point and times A there. And I refer to it as 28.67 dot dot dot. You know, I've put up here, I should have put exact value stored. You know, I've made it clear that I've stored it on my calculator and I'm therefore using the exact value. Also, this angle here is the angle inside the triangle, so that's 123.38, blah, blah, blah. But the bearing is 180 degrees minus that. And well done to those who realised it should be a 3-digit. I'm not really sure what you do when it's one decimal place, but there we go. Anyway, on with the show. So today we're talking about the sine rule, still with non-right angle triangles, still labelled in the same way, big letters, small letters. And the sine rule, you will remember, is all about pairs. So in order to solve a sine rule, a problem using the sine rule, I need to know about a pair, an angle and that side opposite the angle. And the sine rule can be written in two ways. So if I'm trying to find a side, then it's easiest to write it in this way here. And it doesn't matter what letter you have, as long as it's the same letter. So in order to find little a, I need to know the angle opposite, big A, and I also need to know a complete pair somewhere else. So I either need to know little b and big B, or this could be C over sine C. I need to know little c and big C. And again, because I tend to like things to be simple, I often overwrite whatever labelling they've done with A's and B's. So this is how we find sides. Let's just do a couple of examples. So I'm asked in this question to find, to find x and to find y. At first it doesn't look like a sine rule question because I haven't got a complete pair. I don't know an angle and a side opposite anywhere. But of course I can work out x really, really simply because I know the angles in a triangle add up to 180 degrees. So that doesn't involve any complex trig at all. I just know that x is 84, and now therefore I've got my complete pair. I'm trying to find y, so the only thing I now need to check is, do I know the angle opposite y? Bingo. So it's time to go labelling. So I am going to label the side I'm trying to find A and the angle opposite big A, and then the pair I know, I'm going to use B and big B. I can use C and big C if I want. Then going to write down the rule. So the rule is that A over sine A equals B over sine B. A is actually what I'm trying to find, Y, and sine A is sine 57, and B is 7.5. Don't forget little b is the side, big B is the angle. Sine 84, hate fractions, so I'm going to multiply both sides by sine 57. Now I could write that in a number of ways. Here's how I'm going to choose to write it. I'm going to write it like that. I could have written it as that fraction multiplied by sine 57 separately, but I'm going to do it that way, so I can just whack it into my calculator like that. So fraction button 7.5 times sine of 57, and that's over sine of 84. As always, making sure I'm in degrees mode. 3 sig figs is our default, and we're in centimetres. Goody. Okay, so pause and have a go at that one. Again, it doesn't look initially like I know a completed pair, but there are angles I can find firstly, and then I'd like you to work out y. That's our objective here. Okay, so that was 35, so that had to be 85. So I had my completed pair, and I had the pair where I was trying to find the length and I knew the angle opposite. So a labelling I went, little a, big A for the pair that I was trying to complete, and little b, big B for the pair that I already knew, filled it in here. Got to be careful, don't get your 85 and your 35 mixed up, and that gives me 13.9. Now at this point I would always do what I call a reasonableness check. So, you know, is 13.9 a reasonable length in that triangle? Yeah, well, if that's 8, then there's every chance that's 13.9. These triangles are never drawn accurately, but yeah, that seems to make sense. Good stuff. So we can rearrange the sine rule quite easily to get a form that's easy to find missing angles. And I'm sure you remember that it just looks like this. Sine A over A equals sine B over B equals sine C over C. It doesn't matter, but yeah, the rules are the same. I need to know a completed pair, and if I'm trying to find angle big A, I need to know little a opposite it. Okay, so do I know the pair? Yes, I do. I'm trying to find this angle. Do I know the side opposite? Yes, I do. So I'm going to get labelling. Actually, the angle is already labelled A, so that makes that little a. The pair I know, well, the angle's labelled C, so I'm not going to make it into B. I'll leave it as C, and that make that little c. So the rule, I want to find A, so, oh, sorry, sine A over A is sine, is C this time. Doesn't matter what this letter is, as long as it's the same being a little letter. So sine A, well, A is actually called X, 5.8, and sine, so that's sine 67.5 over 7.2. So sine X is equal to, well, I'll tell you what I'm going to do now. I'm going to do it in one go. So sine X will be equal to that times 5.8 divided by 7.2. So that means X is equal to shift sine of that. So I'm going to do it like this. So I've got sine 67.5 times 5.8 divided by 7.2. Now I've done two steps there in one go. Is that okay? So I was about to just multiply both sides by 5.8. So I'd have sine X is sine 67.5 times 5.8 over 7.2. That tells me what sine X is, so I need to shift sine it. Now, of course, I have got the issue that it's a non-right angled triangle, so I could have angles bigger than 90 degrees, and of course we know that sometimes we could have more than one solution. So let's just do this. So I've got shift sine of hit my fraction button, sine 67.5 times 5.8 over 7.2. Now 48.1 degrees, so the other potential angle is 180 minus 48.1, 131, but I've got a 67.5 degree angle elsewhere in the triangle, so it can't be as big as 131.9. So, oh sorry, I've just realised I was drawing a sine curve here and you couldn't see it, so there you go. So that's the angle I found, 48.1. So there's another angle, 180 minus that, with the same sign. But that's 131 is too big because I've got 67.5. Okay, have a go at that question there. I haven't left myself any space to work it out, but pause and have a go at that one. So 48.7, so there's another angle with the same sign. That would be 180 minus 48.7, but I've got 110 angles elsewhere in the triangle, so it couldn't be that. So that's the only potential answer. Okay, so a couple of sort of mixed questions now. Actually, they all involve finding lengths, but anyway, they're sort of slightly less straightforward than the ones we've done so far. I love this question. So we are first asked, we're given all this information, but they've drawn the diagram. So, you know, we could be given this information without the diagram. Hopefully we'd be able to cope. Remember, this is angle ABC from A to B to C, angle ACB, A to C to B. We're asked to calculate AB. So I'm going to give you a chance to pause and think about how you would go about this. I can see three triangles. I can see one here, and then one big one. So which triangle are you going to use to work out AB? Did you spot this? This is an isosceles triangle. So if that's 43, that's also 43. So that's 94. So the first problem is just about that right-hand triangle. So AB is the side I'm trying to find. So I'm going to call that little a. And so the side of angle opposite is big A. And then the pair I know, well, I know both pairs, don't I? I know that and I know that. So I'm going to say that's B, so that's little b. So I'm sort of ignoring the fact that that's already called A. So my rule is I'm finding AB, A over sine A equals B over sine B. So A over sine 94 equals 5 over sine 43. Okay, so hopefully you were able to get to there. So we're then asked to find the length of CD. Now, of course, that was silly because I've crossed that out. So we're asked to find this length here. So I don't know enough about this triangle. I certainly don't know the angle there at the moment. But there are things I can work out. So go on, see if you can get somewhere with that one. Pause and have a go. So I was able to work out the angles. And I've got myself in a bit of a pickle with my labels, haven't I? So I'm trying to find this side. So I'm going to change colour. There you go, changing colour. So let's call that little a. So that's big A, which it was originally anyway. This is big C, so that's now little c. That's my pair, I know, isn't it? I know that that's 5 and that's 72. This is the pair where I know the angle and I'm trying to find the side. So that divided by sine that equals 5 divided by sine that. Go on then, finish that one off for me. Now, when I got that answer, that seemed a little bit small, but if you look at the angles here, this angle is tiny compared with those two. So actually it's just a badly drawn diagram. If that angle was much, much smaller, then it would compress the length of that side. So yeah, we're okay. That is correct. And I promise me, it is correct. So AB was equal to that, and CD is equal to that. Quickly, can you draw me a triangle from this problem? Remember, the bearing is the angle measured clockwise from north. So see if you can draw me a triangle. Don't solve the problem yet. See if you can find me a triangle, or draw me a triangle from this problem. Pause and have a go. Okay, so I've got A, and B is 6 kilometres away on a bearing of 20 degrees, so 20 degrees angle there. And then you've got this town C, which is on a bearing of 55 degrees from A. So are you happy with me putting 35 there? Because that's 55 in total. So it's somewhere along this line, and it's also on a bearing of 120 from B. So it's somewhere along that line, so it's there. And we're asked to find, we've only got time to do one part, we're asked to find the distance of town C from A. So it's this distance that I'm trying to find. So do I know a complete pair in this triangle? Well, at the moment I do not. So I don't know this distance, and I don't know this angle or this angle, but I can calculate this angle, can't I? We sort of did this the other day. So if I draw that line in, this angle here is 60 to make that 180, and I've got alternate angles here, so that's 20. So this angle and this angle is dead angled. So that angle there is actually 80 degrees. Now I'm going to overwrite that with 80, so you may want to pause the video and just double check that and go back. That was 20 because it was alternate angle with that one. These north lines are parallel, aren't they? And then that's 60 to make a half turn. So that's 80 degrees. Right. Do I have a complete pair? Not yet still, but I now know two angles in the triangle, so don't forget I can always do the old 180 take away, so that's 65. Right, do I now know a completed pair? Yes, I do. Do I know the angle opposite the side I'm trying to find? Yes, I do. So I'm trying to find a side, so I'm going to use the sides version of the formula. Go on, pause and have a go. Okay, so actually I sort of broke with a habit of lifetime because it was already labelled A, B, C. The side I was trying to find was the side opposite big B, so that was my little b. So I said little b over sine B is little c over sine C. It doesn't matter. If you relabeled that as A and B, big A and little a, that's absolutely fine. The key thing is that you get this bit right and this bit right, and you've got that answer. And reasonableness check. Yeah, it's reasonable to expect that that is 6.5 if that is 6. This isn't an accurately drawn diagram. If I'd got 20, then I would have thought maybe something's gone wrong. Now, I could do tons of practice questions. I've got a couple more up my sleeve, which I might do when I edit this, I've got enough time. But let's move on to the area formula now, which is the next rule. Sorry, juggling my handouts. Here we go. So the area formula goes back to corners. So it would make more sense to do it with cosine rule, really. If I know about a corner. Now, I have to say I don't write it like this because I am used, when I'm dealing with corners, to deal with A, because that's what we do when we're doing the cosine rule. I call the angle A. So I always have the rule written as a half BC sine A. It doesn't matter. The key thing is you can work out the area of a triangle if you know about the corner of that triangle. So if I know this angle here and the two sides either side of that angle, therefore making a corner, then the area is a half A times B, the two sides multiplied together, times the sine of the angle. And if I know this angle and I know those two sides, then it's the same, but with B and C as my sides and A. And of course, if I know that angle, then the third version would be a half AC sine B. And we saw a proof of that. It was one of the things that Martin Lavelle did as part of the thing on Thursday. I'm not going to do the proof of that. It's not required, but it's quite an interesting proof. You break it into two right angle triangles. Okay, so practice. Easy practice first. I'm not going to pause the video for this one. So the area of this triangle, do I know a corner? Yes, I do. So it is a half times the 2 length. I'm not even going to bother writing the rule. Times the sine of the angle. Okay, simple as that. And how do I do a half? Well, you can do 0.5. You can do a fraction. I'm just going to do 0.5 times 7 times 7.8 times sine of 45. And don't forget we're dealing with area, so lengths are in centimetres, that's centimetres squared. You could do that divided by 2, it would be the same thing, wouldn't it? Okay, so here's a slightly more interesting one. The question is, find the possible values, definite use of the plural there, find the possible values of x. All right, pause and have a go. So this is all about a corner, although because I don't know the angle, but I do know the area. So the angle is called B, so side opposite A is little a, side opposite C is little c. So that's the rule. It doesn't really matter what you call the sides, as long as you get the angle as this is the one that's being signed and the other two sides are the ones you're multiplying. So that's that, and I can do 30 times 40, that's 1200, so a half of that is 600. So sine x is that 2/3. So I'm going to do, I want to find the angle. What angle has that sine? So I'm going to do shift sine of 400 over 600, which is the same as 2/3. and I get 41.8. I'm going to store that. Because the question very clearly said find the possible values, didn't it? And I know that 2/3 is up here. There are two angles. Well, I mean, there's an infinite number of angles, but certainly there are two angles less than 180 which have a sine of 2/3. So I've found one angle is 41.8. So the second angle will be 180 minus that. And as I've stored that one, I'm just going to do 180 minus alpha A. I stored it in A. Round that, so that's 138 degrees. Now, is that possible? Well, it is. I mean, I'm not told anything about these two angles, so that could well be 138. Now, I know it's drawn to look less than a right angle, but of course we don't know how accurately this has been drawn. And it may be that there are two different triangles where these lengths are as they are, which have that area. Well, there are two. I can tell you now. There are two possible values of x. This one obviously would look a different triangle, but it would still have the same lengths and the same area. So I've got a couple of submission questions for you to try. This one involves both using sine rule for sides and angles. And this one is an area question, but it's algebra. So it's one of those ones like we did yesterday where you end up with a problem and you've got to draw this triangle, ABC. You end up with a quadratic equation which you solve. And remember, x is part of a length, so it has to be it has to be positive, it can't be negative. So yeah, these are not straightforward, these two, so I look forward to seeing how you get on with them, and submit whatever you can do. All right, don't feel that you can only submit work once it's perfect and complete. Submit what you can do, then I can help you finish it off, can't I? Take care, and oh well, yeah, last lesson before half term, so I hope you have a super half term. Do take a break, make sure that you are resting, because the work starts again in just over a week, and we're going to start some differentiation. That's the end of trig for now. There's more trig to come, but we'll have a break from it. And yeah, I wish you a great break. Take care.